You know those long, random-looking Bitcoin addresses? Well, turns out they're not random at all. There's actually a secret code hidden inside, a code designed to save you from one of the most common human mistakes, typos. It's called Base58check, and today, we're going to unpack exactly how this clever system works to keep your funds safe. Okay, let's just jump right into a nightmare scenario. Imagine you're sending some Bitcoin. You copy and paste the address, but oops, you accidentally changed just one single character. A G becomes an H. What happens next? Does your money just disappear forever into the crypto abyss? Well, with a lot of other systems, yeah, it would. But Bitcoin has this really smart, built-in safety net to stop that exact disaster from happening. So here's the game plan for this explainer. We'll start with that high-stakes typo problem. Then we'll look at the special mistake-proof alphabet Bitcoin uses. After that, we'll dive into the checksum. Think of it like a spell checker for your crypto. We'll see how the whole address gets put together, and finally, we'll figure out why some addresses start with a 1 and others start with a 3. All right, so let's get down to it. Under the hood, Bitcoin keys and addresses are really just giant numbers. I mean, huge. And the big challenge is, how do you take these massive strings of digits and turn them into something that's, short enough to use, but also safe enough for us clumsy humans to handle? Because, let's be real, one little slip-up could cost you everything. Okay, think about how we count. We use base 10, right? 10 symbols, 0 through 9. But to make really long numbers shorter, computers use systems with a bigger alphabet. You've probably seen hexadecimal, or base 16. That's where they add the letters A through F. Then you have things like base 64, which throws in uppercase letters, lowercase letters, and even a few symbols. It's a simple idea. The more symbols you have to work with, the more compactly you can represent a big number. So Bitcoin's creators looked at this and thought, okay, that's a good start. But they tweaked the idea for a very specific reason, to stop us, humans, from messing up. And that's where Base 58 enters the picture. It's not just about making things short, it's about making things crystal clear. And honestly, the real genius of Base 58 is what isn't in it. They started with a big character set like Base 64, and then they deliberately threw out all the characters that are super easy for us to confuse. Think about it. The number 0 and the capital O? Gone. The lowercase l and the uppercase I? Out of there. They even got rid of the plus and slash symbols because those can cause weird issues when you're copying and pasting on the web. It is such a simple but brilliant piece of human-centered design. And what you're left with is this beautiful, clean alphabet of 58 characters. Every single one is distinct, there's no ambiguity. This massively cuts down the chances of you misreading something or making a typo, which is a lifesaver if you ever, for some reason, have to write one of these things down by hand. So that's the key takeaway right there. Base 58 really hits this perfect sweet spot. Yeah, it keeps the data compact, which is efficient, but its number one job is to be readable for humans and to prevent errors. It's a system truly designed for people, not just for computers to talk to each other. But, even with a great alphabet, we're still human. We can still mess up. So a clear alphabet alone isn't quite enough. That's why there's a whole second layer of security. This is the check part of Base58check, and you can basically think of it as a super-powered spell checker that's built right into every single Bitcoin address. So what is a checksum? The best way to think about it is like a fingerprint. It's a tiny, unique piece of code that's calculated from all the original data. And here's the cool part. If you change even one tiny character in that data, the fingerprint, the checksum, changes completely. And that is the secret to catching mistakes. So how does Bitcoin actually make this fingerprint? Well, it uses a really strong cryptographic process. It takes the address data, it hashes it, which is basically just scrambling it into a unique code, and then, just for good measure, it hashes the result a second time. Then, from that final double-hashed code, it just snips off the first 4 bytes. That tiny little piece, that's your checksum. Okay, this is where the magic happens. When you type or paste a Bitcoin address into your wallet software does that exact same double hash calculation in the background. Then it compares the checksum it just calculated with the checksum that's already part of the address. And if they don't match perfectly, down to the very last bit, the wallet just says, nope, invalid address, and rejects it on the spot. Your money never even leaves your wallet. That little typo costs you nothing. It's brilliant.
Okay, so we've got the main data, we've got our mistake-proof alphabet, and we've got that amazing checksum safety net. So how do all these pieces actually come together to form the final address you see?
Well, there's actually one last piece to this puzzle we need to talk about. It's called the version byte. It's just a tiny bit of data that gets stuck on the very front of everything else. And its job is super simple. It's a label. It tells the wallet software exactly what kind of data it's dealing with. Is it a standard Bitcoin address? Is it one of those more complex ones? Or, hey, is this actually a private key? The version byte answers that question.
So here's the full recipe, from start to finish. You start with your raw data, let's say your public key hash. Step 1, you stick that version byte on the front. Step 2, you calculate the checksum from that whole thing. Step 3, you tack that little 4-byte checksum onto the very end. And finally, step 4, you take this entire package, the version byte, the data, the checksum, and you encode the whole shebang using that special, human-friendly Base58 alphabet. And what comes out the other end? That is your Bitcoin address.
And this whole process, especially that little version byte we just talked about, is the reason you see different kinds of Bitcoin addresses out there. It's what creates these distinct formats that are, again, super easy for us to tell apart with just a quick look.
So check this out. That version byte is what makes all the difference. If you use the version byte for a standard pay-to-public key hash address, a P2PKH, the final address is always going to start with a 1. If you use the version byte for a more complex script address, a P2SH for things like multisig, it's going to start with a 3. And if you're encoding a private key, a different version byte ensures it's going to start with a 5, a K, or an L. So the big thing to get here is that the first character of an address is not random at all. It's a direct result of that version byte. It's like a built-in warning label, an instant visual cue that tells you exactly what you're looking at. It's just one more layer of safety and clarity baked right into the system. So when you put it all together, it's pretty clear that a Bitcoin address is so much more than just a jumble of random letters and numbers. It's a really, really well-engineered piece of technology. I mean, it's just this elegant design that balances everything perfectly. You get compactness, so it's sufficient. You get readability for us humans. You get ironclad security against typos, thanks to the checksum. And you get total clarity from the versioning. Every single piece solves a specific problem, and when you combine them, you get a system that is just incredibly robust. And that kind of leaves us with a bigger thought, right? Base58check is really a masterclass in how to design systems that expect us to be human, systems that anticipate our mistakes and forgive them. It puts clarity and safety first. So the real question is, as our digital world gets more and more complicated, where else can we apply these same ideas? How can we make other technologies not just more powerful, but fundamentally safer and easier for all of us to use?